What is the primary function of the Gaussian process classifier in sklearn? To find the optimal hyperparameters for a given machine learning model using Gaussian processes. To perform Bayesian optimization for a given objective function using Gaussian processes. To perform classification tasks by modeling the probability of a data point belonging to each class using Gaussian processes. To perform regression tasks by modeling the target variable as a Gaussian process. All of the above. Correct. This is a core function of Gaussian process classifier. It models the performance of a machine learning model with a Gaussian process to find the best hyperparameters. A. LTBGT hyperparameter optimization by modeling the performance of a machine learning model as a Gaussian process. You can efficiently search for the best hyperparameters. Hyperparameter tuning. Correct. The Gaussian process classifier can also be used for Bayesian optimization. Using a Gaussian process to find the optimal input values of an objective function. B. Bayesian optimization similar to hyperparameter optimization. It can be employed to optimize an objective function by modeling it as a Gaussian process. Bayesian optimization. Correct. This is the primary function of the Gaussian process classifier. It's designed to model the probability of a data point belonging to each class using Gaussian processes, allowing for classification. C. Classification tasks. It directly performs classification by modeling the probability of a data point belonging to each class using a Gaussian process. Classification of data with nonlinear boundaries. Correct. While primarily a classifier, Gaussian process classifier can be adapted to perform regression tasks by modeling the target variable as a Gaussian process. D. Regression tasks. While not its primary purpose, it can also be used for regression tasks. Modeling the target variable as a Gaussian process. None. Correct. As all the previous options are correct. The Gaussian process classifier is a versatile tool that can be used for all these applications. E. All of the above. None. E. All of the above. A statistical model that represents a function as a probability distribution over possible functions. It assumes that the function's values at different inputs are correlated. Following a Gaussian distribution. A statistical model that represents a function as a probability distribution over possible functions. It assumes that the function's values at different inputs are correlated. Following a Gaussian distribution. Defines the correlation between function values at different inputs. It determines the smoothness and shape of the Gaussian process. Defines the correlation between function values at different inputs. It determines the smoothness and shape of the Gaussian process. Parameters that control the shape and behavior of the Gaussian process and its kernel function. Parameters that control the shape and behavior of the Gaussian process and its kernel function. A global optimization technique that uses a probabilistic model, often a Gaussian process, to guide the search for the best parameters of an objective function. A global optimization technique that uses a probabilistic model, often a Gaussian process, to guide the search for the best parameters of an objective function. The process of finding the optimal values for the hyperparameters of a machine learning model to maximize its performance. The process of finding the optimal values for the hyperparameters of a machine learning model to maximize its performance. The Gaussian process classifier can be used in various scenarios, including hyperparameter optimization for complex models like deep learning models, optimization of expensive black box functions, and classification tasks with nonlinear boundaries. Hyperparameter optimization for complex models, fine-tuning deep learning models with a large number of hyperparameters. Optimization of expensive black box functions, finding the optimal parameters for a simulation model, where each evaluation takes a long time. Classification of data with nonlinear boundaries, identifying complex patterns in datasets where traditional classification methods might struggle. Which of the following is not a key advantage of using Gaussian process regressor for regression? Problems. A. Ability to provide uncertainty estimates for predictions. B. Smooth and continuous predictions. C. Ability to handle high-dimensional data effectively. D. All of the above. Gaussian process regression is known for its ability to provide uncertainty estimates for predictions. This is because it models the function as a distribution, allowing us to quantify the variability in the prediction. Uncertainty estimation. Gaussian process regression produces smooth and continuous predictions. This is achieved through the use of kernel functions that define the smoothness and shape of a predicted function. Kernel function. Gaussian process regression can effectively handle high-dimensional data, while the computational cost can increase with higher dimensionality. It can still provide reasonable predictions. Gaussian process. All of the above statements are true. Gaussian process regression provides uncertainty estimates, produces smooth predictions, and can handle high-dimensional data effectively. Hence, there is no disadvantage mentioned in the question. Solution. D. All of the above. A probabilistic model that defines a distribution over functions. It allows us to capture the uncertainty inherent in the prediction process. Predicting complex, nonlinear relationships in data. Defines the similarity between data points, influencing the smoothness and shape of the predicted function. Optimizing parameters in robotics and control systems. Analyzing and predicting spatial data in geostatistics. Parameters that control the behavior of the Gaussian process, such as the kernel's length scale and noise level. These are optimized during training. Gaussian process allows us to quantify the uncertainty associated with predictions, providing confidence intervals or standard deviations. Estimating uncertainty in financial modeling. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import RBF. Kernel RBF length scale 1.0. GPR Gaussian process regressor kernel. GPR, fit X train. Y train. YPRED. Sigma GPR, predict X test. Returns TD true. This code snippet demonstrates the basic usage of Gaussian process regressor in scikit-learn. It defines a radial basis function RBF kernel, creates a Gaussian process regressor object, fits the model to training data, and then predicts on test data while also obtaining the standard deviation of the predictions. Which of the following Gaussian process kernels are most suitable for capturing periodic patterns in data? A. RBF kernel. B. Linear kernel. C. Polynomial kernel. D. Periodic kernel. The RBF kernel is a radial basis function kernel that measures similarity based on the Euclidean distance between data points. It is commonly used for capturing smooth, nonlinear relationships, but it's not specifically designed for periodic patterns. False. The periodic kernel is specifically designed to model data with periodic patterns. It captures repeating trends and oscillations in the data, making it suitable for applications like time series analysis and signal processing. The linear kernel measures similarity based on the linear dot product between data points. It is suitable for capturing linear relationships, which is not appropriate for periodic patterns. False. The periodic kernel is specifically designed to model data with periodic patterns. It captures repeating trends and oscillations in the data, making it suitable for applications like time series analysis and signal processing. The polynomial kernel measures similarity based on the polynomial dot product between data points. It can capture nonlinear relationships and is suitable for tasks involving complex patterns. But it's not specialized for periodic patterns. False. The periodic kernel is specifically designed to model data with periodic patterns. It captures repeating trends and oscillations in the data, making it suitable for applications like time series analysis and signal processing. The periodic kernel is specifically designed to model data with periodic patterns. It captures repeating trends and oscillations in the data, making it suitable for applications like time series analysis and signal processing. True. The periodic kernel is specifically designed to model data with periodic patterns. It captures repeating trends and oscillations in the data, making it suitable for applications like time series analysis and signal processing. D. Periodic kernel. A statistical model that represents a function as a distribution over functions. They are useful for regression, classification, and probabilistic modeling. Imagine you are trying to predict the temperature in a city over the next year. A Gaussian process could be used to model the temperature as a function of time, taking into account factors like seasonality and weather patterns. It would provide a distribution of possible temperature values for each day, capturing uncertainty and allowing for more robust predictions. Functions that measure similarity between data points. They are used to define the covariance structure of the Gaussian process. Consider you have data on the height and weight of people. A kernel function could be used to measure the similarity between two individuals based on these features. A kernel that considers only the height would be different from one that considers both height and weight. A kernel designed to capture periodic patterns in data. It is characterized by a sinusoidal function that governs the similarity between points. If you are modeling the daily sales of a store that experiences seasonal fluctuations, a periodic kernel could be used to capture the repeating pattern of sales increases during peak seasons and decreases during off-seasons. A radial basis function kernel that measures similarity based on the Euclidean distance between data points. It is commonly used for capturing smooth, nonlinear relationships. Imagine you are trying to predict the price of a house based on its size and location. An RBF kernel could be used to capture the nonlinear relationship between these features and a house price. A kernel that measures similarity based on the linear dot product between data points. It is suitable for capturing linear relationships. If you are trying to predict a student's grade based on their scores on different tests, a linear kernel could be used to capture the linear relationship between test scores and the final grade. A kernel that measures similarity based on the polynomial dot product between data points. It can capture nonlinear relationships and is suitable for tasks involving complex patterns. Suppose you are trying to classify images of animals based on their features. A polynomial kernel could be used to capture the complex relationships between various features in the animal class. Time series forecasting seasonal trends. Signal processing audio. Image analysis. Modeling of cyclic phenomena weather patterns. Planetary orbits. Which of the following statements accurately describe the compound kernel in scikit-learn's Gaussian process regression? A. It allows combining multiple kernel functions. B. It can be used to model complex relationships in data. C. It helps capture different aspects of the data through a combination of kernels. D. All of the above. A. It allows combining multiple kernel functions. This statement is correct as explained in the text. The compound kernel in scikit-learn's Gaussian process regression is a powerful tool for combining different kernel functions. This means you can create a new kernel that incorporates the strengths of multiple individual kernels. The compound kernel in scikit-learn's Gaussian process regression is a powerful tool for combining different kernel functions. B. It can be used to model complex relationships in data. This statement is correct as explained in the text. This allows modeling complex relationships in data by capturing various aspects of the data through a combination of kernels. By combining different kernels, you can capture more intricate patterns that might not be possible with a single kernel. This allows modeling complex relationships in data by capturing various aspects of the data through a combination of kernels. C. It helps capture different aspects of the data through a combination of kernels. This statement is correct as explained in the text. This allows modeling complex relationships in data by capturing various aspects of the data through a combination of kernels. This highlights the ability of compound kernel to represent diverse features of the data through combined kernels. This allows modeling complex relationships in data by capturing various aspects of the data through a combination of kernels. D. All of the above. Since options A, B, and C are all correct, this option is also correct. It encapsulates the combined functionality of the compound kernel. The compound kernel in scikit-learn's Gaussian process regression is a powerful tool for combining different kernel functions. This allows modeling complex relationships in data by capturing various aspects of the data through a combination of kernels. D. All of the above. A non-parametric Bayesian approach to regression that uses a prior over functions. This approach is particularly useful when dealing with data that exhibits nonlinear relationships and uncertainties. Gaussian process regression, a non-parametric Bayesian approach to regression that uses a prior over functions. Functions that measure the similarity between data points. They are used in various machine learning algorithms, including Gaussian processes, support vector machines (SVMs), and kernel principal component analysis (KPCA). Kernel functions that measure the similarity between data points. A radial basis function kernel that measures similarity based on distance. This kernel is often used in scenarios where the data is expected to have smooth nonlinear relationships. The closer the data points are, the more similar they are considered. RBF kernel, a radial basis function kernel that measures similarity based on distance. A kernel that captures linear relationships in data. This kernel is suitable when the data can be well represented by a linear model. It essentially computes the dot product of the input vectors. Linear kernel, a kernel that captures linear relationships in data. A kernel that captures periodic patterns in data. This kernel is particularly useful for modeling data that exhibits cyclical trends or repetitions, such as time series data with seasonal effects. Periodic kernel, a kernel that captures periodic patterns in data. The class for combining kernels in scikit-learn's Gaussian process regression. It allows you to create a new kernel by adding, multiplying, or combining other kernel functions. sklearn, Gaussian process, kernels, compound kernel, the class for combining kernels. Combining kernels like RBF and linear can capture both local and global patterns in data. This is helpful when dealing with data that has both nonlinear trends and linear components. Modeling data with nonlinear relationships. Combining kernels like RBF and linear can capture both local and global patterns in data. Combining kernels like RBF and periodic can handle both short-term and long-term variations in data. This is particularly useful in scenarios where the data has both fine-grained and coarse-grained patterns. Handling multi-scale data combining kernels like RBF and periodic can handle both short-term and long-term variations in data. By combining kernels, you can often achieve more accurate predictions compared to using a single kernel. This is because combining kernels allows you to capture a wider range of relationships in the data. Improving model accuracy by combining kernels. You can often achieve more accurate predictions compared to using a single kernel. Which of the following statements is true about sklearn's constant kernel in Gaussian process? Regression. A. It introduces a constant bias to the model, independent of input features. B. It adds a constant value to the diagonal of the covariance matrix. C. It scales the covariance matrix by a constant factor. D. All of the above. This statement is true. The constant kernel in sklearn's Gaussian process library is designed to introduce a constant bias, modify the covariance matrix in two ways, and scale the covariance matrix. The constant kernel adds a constant value to the mean function of the Gaussian process, effectively introducing a bias independent of the input features. This can be beneficial in cases where your data exhibits a consistent offset. This statement is true. The constant kernel can add a constant value to the diagonal of the covariance matrix. This is useful for adjusting the model's confidence in its predictions. The constant kernel can add a constant value to the diagonal of the covariance matrix. This is useful for adjusting the model's confidence in its predictions. Increasing the diagonal value makes the model more confident, less variance, while decreasing it makes it less confident, more variance. This statement is true. The constant kernel scales the entire covariance matrix by a constant factor. The constant kernel scales the entire covariance matrix by a constant factor. This effectively controls the overall smoothness of the learned function. A larger scaling factor leads to a smoother function, while a smaller factor leads to a more wiggly function. This statement is true. All the above statements about constant kernel in sklearn's Gaussian process regression are true. The constant kernel in sklearn's Gaussian process library is designed to introduce a constant bias, modify the covariance matrix in two ways, and scale the covariance matrix. D. All of the above. Gaussian process, kernel function, covariance matrix, mean function, bias, variance, smoothness, modeling data with inherent bias, adjusting model confidence, controlling function smoothness. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import constant kernel. RBF, kernel constant kernel 1.0 RBF length scale 1.0. GPR Gaussian process regressor kernel. GPR, fit X train. Y train. YPRED GPR, predict X test. In this example, constant kernel with a constant value of 1.0 is combined with an RBF kernel to create a more complex kernel for the Gaussian process. Which of the following statements accurately describes the dot product kernel in sklearn's Gaussian process GP model? A. It measures the similarity between data points based on their inner product in the feature space. B. It introduces periodicity into the GP model, capturing cyclical patterns. C. It models the covariance between data points based on their Euclidean distance. D. It considers the smoothness of the function, favoring gradual changes in the output. True. The dot product kernel in sklearn's Gaussian process GP model defines the covariance between two data points as their inner product in the feature space. This means that the kernel measures the similarity between data points based on how closely aligned they are in the feature space. In essence, the higher the dot product between two feature vectors, the more similar the data points are, and the higher the covariance between them. The dot product kernel is often used for tasks where the underlying data is assumed to have linear relationships in the feature space. The correct answer is A. LTBRGT. False. The dot product kernel does not introduce periodicity. Periodicity is typically captured by kernels like the periodic kernel. B. It introduces periodicity into the GP model, capturing cyclical patterns. False. The Euclidean distance is related to kernels like the RBF radial basis function kernel. The dot product kernel focuses on inner product similarity, not distance. C. It models the covariance between data points based on their Euclidean distance. False. Smoothness is often associated with kernels like the Matern kernel. The dot product kernel prioritizes linear relationships and similarity based on inner product. D. It considers the smoothness of the function, favoring gradual changes in the output. A. Linear regression when the relationship between the input features and the target variable is linear. The dot product kernel can effectively model this relationship, leading to accurate predictions. Imagine predicting house prices based on features like area and number of bedrooms if the price is linearly dependent on these features. The dot product kernel can be effective. Classification for datasets with well-defined linear boundaries between classes. The dot product kernel can assist in building a Gaussian process classifier that effectively separates the classes. In a scenario where you are classifying emails as spam or not spam based on word frequency. If the spam emails have a distinct linear pattern compared to non-spam emails, the dot product kernel can be useful. Dimensionality reduction in scenarios where the number of input features is large. The dot product kernel can be used in conjunction with Gaussian process latent variable models. GPLVMs to reduce the dimensionality of the data while preserving essential information. Consider analyzing customer data with hundreds of features. GPLVMs with the dot product kernel can reduce these features to a smaller set while retaining important relationships for tasks like customer segmentation. Gaussian processes. A non-parametric probabilistic model that provides a flexible framework for regression and classification tasks. Predicting weather patterns based on historical data using a Gaussian process model. Kernels. Functions that measure the similarity between data points. They are crucial for defining the covariance structure in GP models. Using the RBF kernel to model the similarity between images based on their pixel intensities. Covariance function defines the correlation between different data points in a Gaussian process. The choice of kernel dictates the shape of the covariance function. In financial modeling, the covariance function can be used to understand how the prices of different stocks move together. Inner product. A mathematical operation that measures the similarity between two vectors. It is used to calculate the dot product kernel. Calculating the angle between two vectors representing different customer profiles using the inner product feature space. A higher dimensional space where data points are represented as vectors. Kernels map data points to this space, mapping text documents to a feature space based on the presence or absence of specific words. sklearn, Gaussian process, kernels. A module in scikit-learn that provides various kernels for Gaussian process models, including the dot product kernel. Using the module in a Python script to build a GP model for machine learning tasks. Kernel engineering. The process of selecting and designing kernels that effectively capture the underlying relationships in the data. It is a crucial step in Gaussian process modeling. Experimenting with different kernels for a GP model to achieve optimal prediction performance. Gaussian process regression. A GP model used to predict continuous target variables. It is often used for interpolation and smoothing of data. Using a GP regression model to forecast stock prices based on historical data. Gaussian process classification. A GP model used to predict categorical target variables. It can handle complex decision boundaries. Building a GP classifier to identify handwritten digits based on image data. Which of the following statements accurately describes the exp sin squared kernel in scikit-learn's Gaussian process library? It models periodic data with a fixed frequency, using a squared exponential function to define the period. It models periodic data with a variable frequency, using a sinusoidal function to define the period. It models periodic data with a variable frequency, using a squared exponential function to define the period. It models periodic data with a fixed frequency, using a sinusoidal function to define the period. False. Incorrect. The exp sin squared kernel models periodic data with a variable frequency, not a fixed one. False. Incorrect. While it models periodic data, the exp sin squared kernel uses a squared exponential function to define the period, not a sinusoidal function. True. Correct. The exp sin squared kernel models periodic data with a variable frequency, and it uses a squared exponential function to define the period, allowing the frequency to change smoothly over the input space. This makes it suitable for capturing data with varying cyclic patterns. False. Incorrect. The exp sin squared kernel allows the frequency to vary, not remain fixed. C. It models periodic data with a variable frequency, using a squared exponential function to define the period. A probabilistic model that uses a Gaussian distribution to represent the uncertainty in a function. Imagine you are trying to predict the temperature in a city over the next week. A Gaussian process could be used to model the temperature as a function of time, taking into account the inherent uncertainty in the prediction. The model would provide a distribution of possible temperatures for each day, reflecting the confidence in the prediction. Functions that measure the similarity between data points, influencing the shape of the Gaussian process. Think of a set of points scattered on a graph. A kernel function would measure how close 2 points are to each other. This closeness information is used to build a smoother, more continuous function that captures the underlying relationship between the points. A popular Python library for machine learning, including Gaussian process models. In Python, you can use the Gaussian process regressor class from scikit-learn to fit a Gaussian process model to your data. This class provides various kernel functions, including the exp sin squared kernel, which you can use to capture periodic patterns in your data. A specific kernel in sklearn's Gaussian process library designed for modeling periodic data with variable frequency. If you have data like the monthly sales of a product that shows seasonality peaks and dips based on the time of year, the exp sin squared kernel can be used to model this periodic behavior. The kernel can adapt to changes in the frequency of the seasonality over time, making it flexible for capturing complex patterns. Data that exhibits a repeating pattern over time or space, often characterized by cycles or oscillations. Examples of periodic data include monthly sales figures, daily temperature readings, the movement of a pendulum, and the sound waves of a musical instrument. Time series analysis, modeling data with cyclic patterns like seasonal variations in sales or weather patterns. Signal processing, analyzing and predicting signals with periodic components, such as audio signals or sensor data. Which of the following statements accurately describe the exponentiation kernel in Gaussian processors? A. It's a radial basis function kernel that increases its sensitivity to distance as the exponent increases. B. It's a linear kernel that amplifies the effect of feature scaling by the exponent. C. It's a periodic kernel that allows for modeling cyclical patterns, where the exponent influences the frequency. D. All of the above. Correct. The exponentiation kernel can take the form of a radial basis function RBF kernel, where the exponent controls the sensitivity to distance. A higher exponent leads to a steeper decline in similarity as the distance between points increases, making the model more sensitive to local variations. Correct. The exponentiation kernel can also model linear relationships. In this case, the exponent amplifies the impact of feature scaling. A higher exponent emphasizes the contribution of features with larger scaling factors, making the model more sensitive to these features. Correct. The exponentiation kernel can also model periodic functions. The exponent controls the frequency of the periodic pattern. A higher exponent leads to a higher frequency, resulting in more oscillations within the same range of inputs. Correct. The exponentiation kernel is versatile and can capture all these different types of relationships. It's a powerful tool for modeling various data patterns in Gaussian processes. D. All of the above. A probabilistic model that captures the relationships between inputs and outputs as a continuous function. It allows for representing uncertainty in predictions and provides a framework for modeling complex dependencies between data points. Time series forecasting, regression analysis, classification, robotics, computer vision, drug discovery. A function that quantifies the similarity between data points based on their features. It measures how closely related two points are in the feature space, capturing the underlying structure of the data. Clustering, dimensionality reduction, image recognition, natural language processing. A flexible kernel that encompasses various forms, including radial basis functions RBF, linear functions, and periodic functions. It allows for modeling diverse relationships in data, including nonlinearity, smoothness, and periodicity. Time series forecasting, regression analysis, classification, robotics, computer vision, drug discovery. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. Kx1, x2, xp, x1, x22, 2 sigma 2. Kx1, x2, x1, x2. Kx1, x2, exp2 sin 2 pi x1, x2 period 2 sigma 2. The exponentiation kernel can take the form of RBF, linear, or periodic functions. Each form has a parameter that controls its behavior, which can be adjusted to find the best fit for the data. For example, a higher exponent in the RBF kernel makes the model more sensitive to local variations, while a higher exponent in the linear kernel emphasizes features with larger scaling factors. Which of the following hyperparameters is responsible for controlling the smoothness of a Gaussian process model? A. Length scale. B. Signal variance. C. Noise variance. D. All of the above. Length scale. The length scale directly controls the smoothness of the model. A larger length scale indicates a smoother model, implying strong correlation between even distant data points. A smaller length scale leads to a more localized model that captures rapid changes in the data. True. Signal variance. The signal variance influences the overall scale of the data fluctuations, not directly the smoothness. While a high variance implies larger variations in the data, it doesn't necessarily mean the model becomes less smooth. True. Noise variance. Noise variance accounts for the random noise in the data, contributing to the overall smoothness. Higher noise variance tends to smooth out the model, as it assumes more randomness in the data. True. Answer. All three hyperparameters length scale, signal variance, and noise variance contribute to the overall smoothness of the Gaussian process model. The length scale determines the correlation between nearby data points. Signal variance governs the data's magnitude, and noise variance accounts for random noise, all of which influence how the model captures the smoothness of the underlying function. True. D. All of the above. Gaussian process. A statistical model that uses a probability distribution to represent the relationship between input features and output values. It assumes a smooth underlying function that can be represented by a continuous distribution. In essence, it defines a probability distribution over possible functions, predicting the temperature at different locations in a city given historical temperature data at various locations. Kernel function. A function that measures the similarity between two data points. Different kernel functions capture different types of relationships, influencing the model's smoothness, flexibility, and ability to handle complex dependencies. For example, the radial basis function RBF kernel measures the similarity between points based on their Euclidean distance, capturing a smooth, bell-shaped relationship, Kx, x express x, x22, L2. Hyperparameter. Parameters that control the behavior of the model and are not learned from data but set by the user. In Gaussian processes, they govern the shape and smoothness of the underlying function. The length scale L in the RBF kernel is a hyperparameter that controls the smoothness of the model. sklearn, Gaussian process, kernels. A module in scikit-learn, a popular machine learning library in Python that provides pre-built kernel functions commonly used in Gaussian process models. These kernels are designed to capture various types of relationships in the data and can be customized with hyperparameters. You can import and use different kernels from this module from sklearn, Gaussian process, kernels. Import RBF. Matern, constant kernel. Which of the following kernel functions is commonly used in Gaussian process regression for modeling periodic data, where the underlying function repeats itself at regular intervals? A. Linear kernel. B. Polynomial kernel. C. Radial basis function RBF kernel. D. Periodic kernel. LT font style quote font size 14 px quote gt ltbgta ltbgtnbsplineer kerneled font gt. False. The linear kernel models a linear relationship between data points. It is not suitable for modeling periodic data as it lacks the ability to capture repeating patterns. Kernel function. Imagine predicting the price of a house based on its size. A linear kernel would assume a direct relationship between size and price, ignoring potential periodic fluctuations. LT font style quote font size 14 px quote gt ltbgtb ltbgtnbsp polynomial kerneled font gt. False. The polynomial kernel models nonlinear relationships with a higher order polynomial. While it can capture some complex patterns, It's not specifically designed for periodic data. Kernel function. A polynomial kernel could model the relationship between the number of years of experience in a person's salary, but it wouldn't naturally capture cyclical patterns like annual salary increases. LT font style font size 14px GT LTBGTC. LTBGT and BSP radial basis function RBF kerneled font GT. False. The RBF kernel is commonly used for smooth, non-periodic data. It assumes a relationship based on the distance between data points. It's not suitable for capturing periodic trends. Kernel function. The RBF kernel might be used to predict the temperature at different locations within a region, where the temperature changes smoothly but doesn't exhibit a repeating pattern. LT font style font size 14px GT LTBGTD. LTBGT and BSP periodic kerneled font GT. True. The periodic kernel is specifically designed to capture the periodic nature of data, allowing for modeling repeating patterns. It uses trigonometric functions to model the periodicity. Kernel function. The periodic kernel is ideal for modeling the seasonal fluctuations in a time series dataset, like predicting the demand for ice cream throughout the year. D. Periodic kernel. LT font style font size 14px GT LTBGT Gaussian process GP LTBGT LT font GT and BSP LTBRGT LT font style font size 12px GT. A probabilistic model that defines a distribution over functions. LT font GT. A Gaussian process GP is a powerful statistical tool that allows us to model the uncertainty in a function's output. It defines a probability distribution over all possible functions that could have generated our observed data. By doing so, we can not only predict the function's output at new input points but also estimate the confidence in our predictions. Time series forecasting, modeling trends and seasonality in data. Spatial data analysis, predicting values at unobserved locations. Robotics and controlling robot movements based on sensor data. Drug discovery, optimizing molecular properties for desired drug effects. Machine learning, modeling complex relationships between features and outcomes. Consider predicting the daily temperature in a city. A Gaussian process model could capture the overall trend, e.g., warmer in the summer, seasonal fluctuations, e.g., higher temperatures in July, and randomness, e.g., occasional warm days in winter. We can then use the GP to predict the temperature for a future date and quantify our uncertainty about the prediction. LT font style font size 14px GT LTBGT kernel function LTBGT LT font GT and BSP LTBRGT LT font style font size 12px quotient measures the similarity between data points, influencing the shape of the GP. LT font GT. The kernel function in a Gaussian process is the key to capturing the relationships between data points. It measures how similar two data points are based on their input features. The kernel function then influences the shape of the resulting Gaussian process, affecting the smoothness and complexity of the predicted function. The kernel function directly impacts the behavior of the Gaussian process model, as it defines how similar data points are related. For example, the RBF kernel measures similarity based on the distance between points in space. If two data points are close together, the kernel will return a high value, indicating a strong similarity. Conversely, if they are far apart, the kernel will return a low value, signifying a weak similarity. LT font style font size 14px GT LTBGT covariance function LTBGT LT font GT NBSP LTBRGT LT font style font size 12px quotient determines the relationship between the outputs of the GP at different input locations. LT font GT. The covariance function, also known as the kernel function, quantifies the relationship between the outputs of the Gaussian process at different input locations. It essentially tells us how similar the outputs of the function are likely to be at different input points. This information is crucial for making predictions. The covariance function directly determines the structure of the predicted function, impacting the smoothness and complexity of the model. In time series analysis, the covariance function could model the correlation between temperature readings at different times. If the readings are close in time, they are likely to be more similar than readings far apart in time. LT font style font size 14px GT LTBGT hyperparameters LTBGT LT font GT NBSP LTBRGT LT font style font size 12px quotient parameters that control the behavior of the kernel, influencing the model's smoothness and complexity. LT font GT. Hyperparameters in a Gaussian process model are parameters that are not learned from the data directly but are set by the user. These parameters control the behavior of the kernel function, determining how similar data points are assumed to be and, ultimately, influencing the overall smoothness and complexity of the predicted function. Hyperparameters are crucial for tuning the Gaussian process model to achieve the best performance on a given dataset. They control the balance between bias and variance in the model. For example, in an RBF kernel, the hyperparameter length scale controls how quickly the similarity between data points decays with distance. A large length scale will result in a smoother function, while a small length scale will lead to a more complex function that captures local variations in the data. LT font style font size 14px GT LTBGT regression LTBGT LT font GT NBSP LTBRGT LT font style font size 12px quotient predicting continuous output values based on input data. LT font GT. Regression is a type of statistical analysis that focuses on predicting continuous output values based on input data. Gaussian process regression is a powerful approach to regression, allowing us to model the uncertainty in our predictions and make them more robust. Regression problems are ubiquitous in various fields. They can be applied to predict house prices, stock prices, weather patterns, customer behavior, and many more. If we have data on the relationship between the size of a house and its price, we can use Gaussian process regression to model this relationship and predict the price of a new house with a given size. The model can also provide us with confidence intervals, reflecting our uncertainty about the predicted price. Which of the following statements accurately describes the Matern kernel in scikit-learn's Gaussian process implementation? A. The Matern kernel is a smooth, non-oscillatory kernel suitable for modeling data with varying degrees of smoothness. B. The Matern kernel is highly oscillatory, making it ideal for capturing periodic patterns in data. C. The Matern kernel's smoothness is controlled by a parameter, nu, influencing the degree of regularity in the function it models. D. All of the above. True. The Matern kernel indeed is a smooth kernel, meaning it generates functions that are continuous and differentiable to a certain degree. This smoothness makes it suitable for modeling data where trends are expected to be gradual, without rapid oscillations. True. The Mattern kernel is not highly oscillatory. While it can capture some periodic patterns, it is primarily designed for capturing smooth trends. True. The Mattern kernel's smoothness is regulated by the parameter nu. This parameter controls the degree of regularity in the function it models. Higher values of nu indicate a smoother function, while lower values suggest a more irregular one. True. All of the above statements are true. The Mattern kernel is smooth, non-oscillatory, and its smoothness is controlled by the parameter nu. D. All of the above. Gaussian processes, kernel functions, covariance functions, kernel hyperparameters, scikit-learn sklearn, Gaussian process regressor, Gaussian process classifier, Mattern kernel, nu parameter, smoothness, regularity, spatial data analysis. The Mattern kernel can be used to model the spatial correlation of soil properties. For example, the Mattern kernel could be used to model the gradual decay of soil pH with distance from a measurement point. Time series forecasting. The Mattern kernel can be used to model both seasonal and trend components in time series data. For example, the Mattern kernel could be used to forecast the number of passengers on a train line, taking into account both seasonal fluctuations and the overall growth of the passenger base. Machine learning. The Mattern kernel can be used in various machine learning tasks, such as regression and classification. For example, the Mattern kernel could be used to build a Gaussian process model to predict the price of a house, given features such as its size, location, and age. How does the pairwise kernel function from scikit-learn's Gaussian process library handle different data points in a dataset? It calculates the distance between all data points and then applies a kernel function to those distances. It considers only the pairwise relationships between data points, ignoring the overall dataset structure. It leverages a custom function to compare pairs of data points based on specific features. All of the above. It calculates the distance between all data points and then applies a kernel function to those distances. This statement is partially true. Pairwise kernel calculates distances between data points but doesn't necessarily apply a kernel function to all distances. The kernel function is applied only to the pairwise distances, not to the distances between all data points. False. It considers only the pairwise relationships between data points, ignoring the overall dataset structure. This statement is true. Pairwise kernel focuses on comparing pairs of data points, without taking into account the global structure of the entire dataset. It measures the similarity between pairs of data points without considering the overall datasets. Distribution. True. It leverages a custom function to compare pairs of data points based on specific features. This statement is also true. Pairwise kernel allows you to specify a custom distance metric function metric parameter to compare pairs of data points based on specific features. For example, you can use Euclidean for standard Euclidean distance, Manhattan for Manhattan distance, or define your own custom function. True. All of the above. This statement is correct. Pairwise kernel calculates pairwise distances, considers only pairwise relationships, and uses custom functions to compare pairs based on specific features. True. D. Gaussian process. A statistical model that uses a distribution over functions to represent the relationship between input and output variables. It provides a probabilistic framework for modeling complex relationships between data points, predicting stock prices based on historical data, estimating the temperature at a specific location based on weather patterns, modeling the trajectory of a robot in a dynamic environment, Kernel function. A mathematical function that measures the similarity between two data points in a dataset. It quantifies how similar or dissimilar two data points are, based on their features. Detecting spam emails by analyzing the similarity between email content and known spam patterns. Recognizing images by comparing the similarity between image features and known object. Representations. Clustering data points based on their similarity measures. Kernel matrix. A square matrix where each element represents the similarity or distance between two data points. Using a kernel function, it provides a compact representation of pairwise relationships within a dataset. Performing dimensionality reduction techniques like principal component analysis (PCA) to identify the most important features in a dataset. Building machine learning models like support vector machines (SVMs) for classification and regression tasks. Visualizing complex data relationships using techniques like heat maps and dendrograms. Regression. Predicting continuous values, like stock prices or temperature. Gaussian processes can be used to model the relationship between input variables and continuous output variables, providing uncertainty estimates for the predictions. Forecasting future stock prices using historical data and economic indicators. Predicting the temperature at a specific location based on past weather data and current atmospheric conditions. Estimating the price of a house based on its features, location, and market trends. Classification. Categorizing data into different groups, like spam detection or image recognition. Gaussian processes can be applied to classify data points into distinct categories based on their features and relationships. Detecting spam emails by analyzing the similarity between email content and known spam patterns. Classifying images into different categories, such as animals, vehicles, or landscapes. Predicting the outcome of a disease based on patient medical history and symptoms. Time series analysis. Modeling and forecasting time-dependent data, like weather patterns or website traffic. Gaussian processes can be used to model and predict the future behavior of time series data, capturing both trends and seasonality. Forecasting future weather patterns based on historical data and current meteorological conditions. Predicting website traffic based on past trends and seasonal patterns. Analyzing stock market trends and predicting future market movements. From sklearn, Gaussian process, kernels import pairwise kernel. Kernel pairwise kernel metric Manhattan. Print kernel. This code snippet demonstrates how to create a pairwise kernel object in scikit-learn. The metric parameter is set to Manhattan, indicating that the Manhattan distance will be used to calculate pairwise distances between data points. What is the primary advantage of using the product of two Gaussian process kernels K1x, K2x, X compared to using either K1 or K2 individually? Increased computational efficiency, enhanced ability to model complex relationships, reduced risk of overfitting, all of the above. Computational efficiency. The product of kernels often results in computationally more efficient models, as the complexity is not significantly increased compared to using individual kernels. This statement explains that the product of kernels doesn't add much complexity, which keeps computation time reasonable. False. The product of two Gaussian process kernels K1x, X and K2x, X yields a new kernel that embodies the characteristics of both individual kernels. By combining the strengths of both kernels, the product can represent intricate relationships not possible with individual kernels. For instance, if one kernel captures short-term trends and the other captures long-term trends, Their product can model both effectively. True. Overfitting. By incorporating features from both kernels, the model avoids solely relying on the characteristics of a single kernel, which can lead to overfitting. This helps the model generalize better to unseen data. True. Answer. The product of kernels provides the advantages of enhanced relationship modeling, computational efficiency, and reduced overfitting, making all of the above the correct answer. It's the most comprehensive option, encompassing all the benefits. True. All of the above. A probabilistic model that assumes a Gaussian distribution for the function being modeled. It's widely used in regression, classification, and time series forecasting. Consider predicting house prices based on features like area and bedrooms. A GP can model this relationship by assuming that the price is distributed normally, with a mean and variance determined by the features in a kernel function. A function that measures the similarity between data points, determining the smoothness and shape of the underlying function in the GP. A common kernel is the radial basis function RBF kernel. It's used in image recognition to assess the similarity between pixels. If two pixels are close, their RBF kernel value will be high, indicating high similarity. Combining multiple kernels through multiplication, allowing for more complex relationships between inputs and outputs. In time series forecasting, one kernel might capture seasonal patterns, and another might capture trends. Their product can effectively model both seasonality and trend together, resulting in more accurate predictions. The product of kernels often results in computationally more efficient models, as the complexity is not significantly increased compared to using individual kernels. In a large-scale image classification task, using a product of kernels to represent complex features may be faster than using a single, overly complex kernel. A scenario where a model learns the training data too well, failing to generalize to unseen data. If a kernel only focuses on the training data, it might learn very specific patterns that don't apply to new data. This leads to overfitting and poor performance on unseen data. Time series forecasting, predicting future values based on historical data, often incorporating seasonal patterns and trends. Forecasting daily sales of a product using past sales data, taking into account seasonal variations and trends over time. Image recognition, classifying and identifying objects within images, often using kernels to capture spatial relationships between pixels. Identifying cars, pedestrians, and traffic lights in a video feed using a GP model that employs kernels to analyze spatial relationships between pixels. Natural language processing (NLP), analyzing and understanding human language, often using kernels to capture semantic relationships between words. Developing a chatbot that can understand and respond to natural language queries using kernels to represent semantic relationships between words in a sentence. LT font style quote font size 16 px quote GT LTBGT question LTBGT LT font GT NBSP LTBRGT WH80 is the primary use case of the radial basis function RBF kernel in Gaussian process regression GPR. LTBRGT LT font style quote font size 14 px quote choose the most appropriate option LT font GT. A. Modeling highly nonlinear relationships. B. Handling large datasets efficiently. C. Identifying the optimal number of hidden layers in a neural network. D. All of the above. A. Modeling highly nonlinear relationships. Correct. The RBF kernel excels at capturing nonlinear patterns in data. It assumes that points closer together in the input space should be more similar in the output space. This property makes it suitable for modeling complex relationships. Let's visualize this with an example. Consider predicting the price of a house based on its size, number of bedrooms, and location. This relationship is likely nonlinear. Larger houses with more bedrooms in desirable locations tend to have higher prices. But this relationship might not be strictly linear. True. B. Handling large datasets efficiently. Correct. While GPs are not inherently known for handling massive datasets, the RBF kernel can contribute to efficiency by enabling a sparse approximation of the GP model. This allows handling larger datasets without sacrificing accuracy. In practice, sparse GP methods with the RBF kernel can be used for larger datasets compared to dense GP models. True. C. Identifying the optimal number of hidden layers in a neural network. Incorrect. The RBF kernel is used in the context of Gaussian processes, not neural networks. While both deal with modeling data, their approaches and applications differ. Identifying the optimal number of hidden layers is a key hyperparameter optimization problem in deep learning, typically addressed using techniques like grid search, random search, or Bayesian optimization. False. D. All of the above. Correct. All the above statements are true. The RBF kernel in GPR is indeed capable of modeling highly nonlinear relationships, handling larger datasets efficiently through sparse approximations, and is a versatile choice for various applications. True. D. All of the above. LT font style font size 14px Gaussian processes GPS LT font GT LTBR GT LT font style font size 12px GTA probabilistic approach for modeling functions. GPs provide a distribution over possible functions, capturing uncertainty. LT font GT. Imagine you have a set of data points representing the height of a plant over time. A GP would not just give you a single line as a prediction but a distribution of possible lines, reflecting the uncertainty in the growth pattern. This uncertainty is captured by the variance of the distribution. Time series forecasting predicting future values of a time-dependent variable, e.g., stock prices, weather patterns, robotics and control systems designing controllers that can adapt to dynamic environments. Machine learning models GPs can be used as a prior or in Bayesian optimization to find optimal parameters. LT font style font size 14px GT kernels in GPS LT font GT LTBR GT LT font style font size 12px GT measure similarity between data points. Different kernels define various assumptions about data relationships. LT font GT. Imagine you have two data points representing the age and height of two people. A kernel function would measure the similarity between these points based on their age and height. A common kernel like the RBF kernel assumes points closer in both age and height are more similar. Modeling various relationships linear, nonlinear, periodic, etc. Capturing different aspects of data smoothness, periodicity, trends. Choosing the right kernel can significantly impact the performance of a GP model. LT font style font size 14px radial basis function RBF kerneled font GT LTBR GT LT font style font size 12px GT a popular kernel in GPs that models smoothness and nonlinearity. Its shape is characterized by a distance function, often Gaussian. LT font GT. The RBF kernel typically uses a Gaussian function to calculate similarity. This means that points closer together in the input space are considered more similar. and the similarity decays exponentially as the distance increases. This can be visualized as a bell-shaped curve centered around each data point. Modeling complex relationships in time series analysis. Developing robust controllers for robots. Predicting protein structures in bioinformatics. LT font style quote font size 14px quotient hyperparameter tuning LT font GT LTBR GT LT font style quote font size 12px quotient the process of adjusting parameters within the kernel, e.g. length scale in the RBF kernel to optimize model performance. LT font GT. Consider the RBF kernel. Its length scale parameter controls the smoothness of the resulting function. A smaller length scale leads to a more wiggly function, while a larger length scale results in a smoother function. By tuning the length scale and other hyperparameters, we can find the optimal configuration for our GP model, improving the accuracy of GP models, making GP models more robust to noise, ensuring the GP model is well suited to the specific problem. LT font style quote font size 14px quote sklearn, Gaussian process, kernels, RBF LT font GT LTBR GT LT font style quote font size 12px quotient the RBF kernel implementation in scikit-learn sklearn for use with Gaussian process regression. LT font GT. Let's say you want to use an RBF kernel with a Gaussian process regressor in Python. The sklearn, Gaussian process, kernels, RBF class provides a convenient interface to utilize the RBF kernel. You can simply create an instance of this class and specify the desired length scale. For example, to use an RBF kernel with a length scale of 1.0, you would write from sklearn, Gaussian process, kernels import RBF kernel RBF length scale 1.0. Using the RBF kernel within the scikit-learn framework, leveraging the efficiency and ease of use of scikit-learn for GP models. Combining the RBF kernel with other kernel functions to model more complex relationships. Which of the following statements best describes the rational quadratic kernel RBF in the context of Gaussian process regression? The RBF kernel is highly flexible, allowing for nonlinear relationships between inputs and outputs. It provides a smooth interpolation between data points, making it suitable for scenarios where the underlying function is expected to be smooth. The RBF kernel is best suited for data exhibiting strong periodic patterns, such as time series data. It captures the repetitive nature of such data effectively. The RBF kernel is ideal for capturing discontinuities in the data, effectively handling abrupt changes in the output values. The RBF kernel excels in modeling data with long-range dependencies, allowing for accurate predictions even when there are significant gaps between data points. The rational quadratic kernel RBF is a powerful kernel function often used in Gaussian process regression. It is known for its ability to model nonlinear relationships between input variables and output values, providing a smooth interpolation between observed data points. True. The rational quadratic kernel RBF is indeed known for its ability to model nonlinear relationships and provide smooth interpolation between data points. This makes it suitable for situations where the underlying function is expected to be smooth. The RBF kernel is best suited for data exhibiting strong periodic patterns, such as time series data. It captures the repetitive nature of such data effectively. False. While the RBF kernel can handle some periodicity, it is not the most suitable kernel for data with strong periodic patterns. Kernels like the periodic kernel or the spectral mixture kernel are better suited for such data. The RBF kernel is ideal for capturing discontinuities in the data, effectively handling abrupt changes in the output values. False. The RBF kernel, due to its smooth nature, is not suitable for capturing discontinuities in data. Kernels like the Matron kernel with a low smoothness parameter or the linear kernel might be more appropriate for such situations. The RBF kernel excels in modeling data with long-range dependencies, allowing for accurate predictions even when there are significant gaps between data points. False. While the RBF kernel can model long-range dependencies, it might not be the best choice for data with very significant gaps. In such cases, kernels specifically designed for long-range dependencies, like the exponential kernel, might perform better. A probabilistic approach to regression where a Gaussian process is used to model the underlying function, providing not only predictions but also an estimate of uncertainty. Imagine you have a dataset of house prices and their corresponding sizes. Using Gaussian process regression, you can model the relationship between size and price, not just predicting the price for a specific house size, but also providing a range of possible prices with their probabilities. Functions that define the relationship between data points in a Gaussian process. They determine the smoothness, periodicity, and other characteristics of the modeled function. Consider a dataset of temperatures over time. Different kernel functions can be used to capture different patterns in the temperature data. For example, a linear kernel might be appropriate if the temperature is linearly increasing, while a periodic kernel would be suitable if the temperature exhibits seasonal variations. A widely used kernel in Gaussian processes that provides a smooth interpolation between data points, allowing for the modeling of nonlinear relationships. It is parameterized by a length scale and a scaling factor, which control the smoothness and amplitude of the modeled function, respectively. Imagine a dataset of car fuel efficiency as a function of its speed. The rational quadratic kernel can be used to model the relationship between speed and fuel efficiency. The length scale determines how quickly the fuel efficiency changes with speed, while the scaling factor influences the overall amplitude of the efficiency. Function approximation, time series prediction, image analysis, robotics. Using Gaussian process regression with an RBF kernel, you can approximate the function that relates the number of hours studied to exam scores. This can be useful for predicting the exam score for a student based on their study hours. Predicting the future stock price of a company based on historical data using Gaussian process regression with an RBF kernel. Considering the trend and volatility of the stock market. Using Gaussian process regression with an RBF kernel for image denoising. The kernel can effectively smooth out noise while preserving the important features in the image. Controlling the movement of a robot arm based on sensory feedback using Gaussian process regression. With an RBF kernel, the kernel can capture the complex relationship between sensory input and motor commands, enabling the robot to move smoothly and accurately. Which of the following statements accurately describe the behavior of the sum kernel in scikit-learn's Gaussian process models? It combines the strengths of multiple kernels by adding their individual outputs. It scales the output of a base kernel by a constant factor. It adds a constant offset to the output of a base kernel. All of the above. It combines the strengths of multiple kernels by adding their individual outputs. This statement is correct. The sum kernel combines the outputs of multiple kernels by adding them together. This allows for the creation of more complex models that can capture different aspects of the data. True. It scales the output of a base kernel by a constant factor. This statement is also correct. The sum kernel can scale the output of a base kernel by a constant factor. This allows for adjusting the relative influence of different kernels. True. It adds a constant offset to the output of a base kernel. This statement is also correct. The sum kernel can add a constant offset to the output of a base kernel. This can be used to introduce a bias term into the model. True. All of the above. This statement is correct because A, B, and C are all true statements describing the behavior of the sum kernel. True. D. All of the above. Gaussian process GP. Kernel functions. Radial basis function RBF kernel. Linear kernel. Sum kernel. Scikit-learn. Time series forecasting. Regression analysis. Classification. Image analysis. 1, 2, 2, 4, 3, 6. RBF kernel. Linear kernel. Sum of RBF and linear kernels. The sum kernel allows us to combine different kernels to capture both linear and nonlinear relationships. For instance, if we have a dataset with both linear and nonlinear trends, we can use a combination of an RBF kernel and a linear kernel to model the data more effectively. What is the primary function of the white kernel in scikit-learn's Gaussian process? It introduces a bias term into the Gaussian process model, potentially improving model fit. It serves as a scaling factor for the kernel, allowing you to adjust the overall influence of the kernel. It introduces a constant term to the Gaussian process kernel, allowing for a non-zero mean function. It is responsible for defining the correlation between input points in the Gaussian process, influencing its smoothness and flexibility. A. It introduces a bias term into the Gaussian process model, potentially improving model fit. Incorrect. While bias can be introduced in Gaussian processes, the white kernel specifically adds a constant term, not a bias term. Bias is related to the model's tendency to make consistent errors, often arising from model assumptions. Bias variance trade-off. Model complexity. B. It serves as a scaling factor for the kernel, allowing you to adjust the overall influence of the kernel. Incorrect. Scaling the kernel's influence is achieved through hyperparameter optimization, not directly by the white kernel. The white kernel primarily focuses on introducing a constant term. Kernel hyperparameters. Hyperparameter optimization. C. It introduces a constant term to the Gaussian process kernel, allowing for a non-zero mean function. Correct. This is the primary function of the white kernel. It adds a constant value to the kernel, resulting in a non-zero mean function, which can be useful for modeling data with a consistent baseline value. Kernel function. Mean function. Constant kernel. D. It is responsible for defining the correlation between input points in the Gaussian process, influencing its smoothness and flexibility. Incorrect. This function is typically handled by other kernels, like the RBF kernel, which define the relationships between input points. The white kernel is a constant kernel and doesn't directly contribute to the correlation structure. RBF kernel. Kernel function. Correlation structure. C. It introduces a constant term to the Gaussian process kernel, allowing for a non-zero mean function. 1. LT font style quote font size 14 px quotient modeling data with non-zero mean when your data exhibits a consistent baseline value, e.g., stock prices with a general upward trend. A white kernel can be used to capture this non-zero mean behavior. LT font GT. The white kernel introduces a constant term that allows the model to capture a consistent baseline value in the data. even when input points are far apart. This is useful when the data doesn't oscillate around zero, like in stock prices with a general upward trend. Imagine you are predicting the price of a particular stock. The stock prices typically show an upward trend over time. Using a white kernel would allow the Gaussian process model to capture this general upward trend, providing a more accurate prediction than a model without it. Let's say the stock price is represented by Y, and the time is represented by X. We can use a Gaussian process to model the relationship between Y and X. The white kernel would introduce a constant term C to the model. So the predicted price would be YFXC. This C captures the general upward trend in the stock price. 2. LT font style quote font size 14px quotient regularization. The constant term introduced by white kernel can act as a regularization technique, preventing the Gaussian process model from overfitting to the training data. LT font GT. Regularization helps prevent overfitting by adding a penalty to complex models, encouraging simpler models that generalize better to unseen data. The white kernel acts as a regularizer by adding a constant term to the model, reducing the complexity and preventing the model from fitting the training data too closely. If you are training a Gaussian process model to predict the temperature on a given day, using a white kernel can prevent the model from overfitting to the training data and making inaccurate predictions for days with different conditions. The constant term acts as a regularizer, preventing the model from becoming too complex and capturing only the specific patterns in a training data. Gaussian process. A statistical model that uses a kernel function to define the relationships between data points. It's used for regression and classification tasks, especially when the data exhibits complex relationships. Imagine you want to predict the temperature of a city based on historical data. You can use a Gaussian process to model the complex relationships between factors like time, weather, and location to accurately predict the temperature. Kernel function. A function that defines the similarity between data points. It determines the smoothness and flexibility of the Gaussian process model. Think of a kernel function as a way to measure how close two data points are. For example, a radial basis function RBF kernel defines the similarity based on the distance between points. Closer points will have a higher similarity, while farther points will have a lower similarity. Constant kernel. A type of kernel function that introduces a constant term to the model. It doesn't directly define the correlation between data points, but it allows for a non-zero mean function. Imagine you are modeling the growth of a plant. If you know the plant grows at a constant rate, you can use a constant kernel to model this constant growth behavior. White kernel. A specific type of constant kernel used in scikit-learn's Gaussian process implementation. It introduces a constant term to the kernel function, effectively adding a non-zero mean function. In a machine learning model for predicting the stock price of a company, a white kernel can be used to capture a constant baseline value for the stock price, even when the company's performance fluctuates. Mean function. The average value of the predicted output for a given input in a Gaussian process model. The white kernel contributes to a non-zero mean function. In a model predicting the temperature, the mean function would represent the average temperature expected at a given time and location. Regularization. A technique used to prevent overfitting in machine learning models. Regularization introduces penalties for complex models, encouraging simpler models that generalize better to unseen data. In a model predicting customer churn, regularization techniques like L1 or L2 regularization can help prevent the model from overfitting. to the training data and accurately predict customer churn in new customers.